Okay, now we're going to look at determining the domain and range of continuous relationships and just looking at equations. Remember, this is an equation, and the only difference between an equation and function is the following. In an equation, you have y equals whatever. In a function, you have the following notation. Function of x equals, or you could have g of x equals, or you could have b of x equal whatever the letter might be. It's the only difference. So the difference is that an equation is y equals, and in a function it has this notation. Okay, that's it. Let's make our thinking visible before we move forward. Remember that the domain are all the possible values, the possible x values. And as you look over here, x values, we have no restrictions. We have absolutely no restrictions. So this x equal from negative infinity to positive infinity, semicolon. Therefore, x equals all real numbers. You can add anything to it, to 7. For example, y equals 10 plus 7, y equals 17. That's example 1. Y equals negative 378 plus 7, y equals negative 371. So that's going to be an easy one. Number 2 is asking us for the domain and the range. Again, let's make our thinking visible. Let's look at domain, our x values, and the range, our y values. This is also our input. Let's underline the word in because it's what's going in. And y values is our output. And underline out because it's what's coming out. Now, on this one is very similar. Very, 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 very similar. The domain. The domain can be all real numbers. All real numbers. Comma. Because there are no restrictions, comma, in any x value can b raised to the second power. What do I mean by that? If I look at the equation, it can be raised to the second power. Okay. For example, if I have -3 raised to the second power equals 9, the positive result. Second power, I'm going to write this down. This is an unspoken rule. Always, you have to memorize this. Always positive. Anything to the second power, anything to the fourth power, anything to the sixth power, anything that isn't even numbers, it's always positive. So that's our domain. In our range, our result is always going to be greater than 3. I know that because of this. It's always greater than 3. I'm going to demonstrate this for you. Always greater than, greater, or equal actually, or equal than 3. Let's demonstrate this. I'm going to go ahead and set my function to be equal to 3. Oh, by the way, that is my range. Okay, here we go. The function of x equal 3 plus x squared. Easy. Equal 3 plus, let's say 0. All right, to the second power. 0 to the second power is 0. Therefore, the function is equal to 3. Now I have satisfied, I have satisfied this part. Now let's satisfy this other part. Greater than 3. Greater than 3. And I don't have to pick anything complicated. The function of x equals 3 plus x squared equals 3 plus, it could be -1 or it could be 1. It doesn't matter. It's always going to be positive because of my little unspoken rule. So 3 plus, again, -1 to the second power is the same thing as having this. -1 times -1 equals +1. And then I'm going to write over here equals 4. So now we have satisfied the second part. Therefore, my domain and range are as follow. I'm going to express it like this. My domain goes from -infinity to +infinity. Semicolon. And my range includes 3 to positive infinity. Oh, I skipped an e. There you go. Okay. Be sure that you use the colors so that you can trace your thinking back. Again, this 3 right here comes from here, and the infinity, positive infinity, is this part. Okay, now let's look at the given function. Okay, we're looking at the domain range again. Domain, x values, range, y values. And here's the curious thing. Because I have an absolute value, my y values are going to be immediately all positive numbers. So again, I know that my y values are always positive. Because of the absolute value. Again, I'm going to highlight that absolute value in green. That's why. And my domain, my x values are all real numbers because I have no restrictions. There are no restrictions. So I can say, so I'm going to show you 3 ways to express this. 3 mathematical ways. So let's start with this. The domain equals all real numbers. That's option 1. Option B, you can say that the domain, that looks more like a P, let me go ahead and change it, equals from negative infinity, it can be 0, and it can be to positive infinity. So this right here is going to help us understand how to express the answer as an inequality. Remember, inequalities are this. Okay. I'm going to call this B.1. So that's the third option. B.1, I can say that the domain equals from negative infinity, and x is in between, negative infinity or positive infinity. This is the most appropriate way to express that. Let's test it out. Y equals absolute value of x plus 1. Okay, so we say that, let's say y equals absolute value of 0 minus 1. Y equals value negative 1, y equals 1. And finally, let's look at example number 4. And example number 4 does have a restriction. So let's look at our restriction first. We have a fraction right here. Rule. When a over 0, comma, answer is undefined. That's how we're going to express that. In simpler terms, we cannot divide a number by 0 the denominator cannot be 0. Okay, that's what I'm trying to tell you. So immediately this little x has to be, or let's define it this way, cannot be 0. Cannot be 1. Let's talk about why. It cannot be 1 because 1 minus 1, I'm getting this minus 1 from here, equals to 0. And therefore, when 4 divided by 0, I'm getting this 4 from here. Okay. Then it's undefined. Goes back to this rule. So I can say that my domain so the question is only asking me for domain. I'm gonna show you the domain and range. So my domain equals all real numbers, with the exception of 1. With the exception of 1 in math terms. That equals exception of 1. In my range, I want you to look at this positive 5. It's very similar to this example right here. It has to be always greater or equal to 5. So range is always greater or equal to 5. So my range is 5, including 5, comma, positive infinity. And that is it. Again, if you have any more questions, please feel free to watch the video. with the notes, read your instructions. I am here to support you in whatever you need. And please attend to Algebra Club so that we can have some extended practice.